is going to be minus 4. And it's got to come down to the minus 4 and touch, go up, and somehow cross at 1, like that. Okay? Okay, I got to talk fast now. But that's okay, because chapter 5 should be fresh in your mind. Okay. I know you forgot this. What kind of function? Got horizontal and vertical asymptotes, maybe oblique. Okay, so let's factor this. On the bottom, it's going to be 2x, x, 1 and 3, 1, 3, minus and plus. Now you notice that x minus 1 doesn't cancel up on the top. Okay, so what's its vertical asymptote? Where do they come from? Comes from these numbers here, doesn't it? Okay. So at x equal to 3, there's an asymptote. What else? X equal to what? Minus 1/2. Okay. Now, tricky, treacherous point. I want the horizontal asymptote. What do I do? Long division? Synthetic division? No synthetic division. Okay. Maybe long division. Do I have to do long division here? No. Yeah, because these are the same order, right? Okay, same order. So this horizontal asymptote is going to be y equals, I key on those, 3 over 2. Just like that. Now there's some variations when you go through your worksheet, right? The cheat sheet you're going to have. Here's a whole new problem. Say I had a whole new problem. And I got this as the answer. What changed? This would cancel out, wouldn't it? What would this, let's see, the asymptote on the bottom, let's see, would be 1/2. This would be x equal to 1, but what would that signify? Is that an asymptote? It's a hole, right? Okay. Say that this was to, well, that doesn't make much sense. Say it was this. This number here is bigger than the number 1. What's the horizontal asymptote? Okay, it's because it's proper. So there's all, yeah, you read that sheet. Okay, there's always going to be one asymptote. Say it was this. Yeah, that's the killer, isn't it? That's the killer. Now I got to do long division, right? Because this is exactly 1 bigger than this. Okay. Okay, so those are the variations. Those are the variations. Okay. 2, 5, 5. Let me jump to 5, 6, because I want to make sure I do this problem. And we'll have time at the end to do another one. Number 23. Okay. Okay, this is the last section we did in chapter 5. And this is a kind of a interesting problem. They're trying to help you, because if I just ask you to get these roots, this might take you a while, because there's some imaginary roots. X to the, no, just x to the third. X to the third minus 4x plus 4x minus 16. Can you guys all see that in the back? Okay, I'm wondering if the camera picked up. Now they give you some extra information. Use the given zero to find the remaining zeros of the polynomial function. The given zero, the piece of other information they gave you, is that what was hidden here was a minus 2i. So somebody already worked on this and said, okay, there's a minus 2i. Now what other root do I know I have if that's the case? Yeah, so I got a positive 2i, because they always come in a pair. It says, well, find the other polynomial root. How the heck am I going to do that? Can I put these together and make it something reasonable? Yeah, these are not real roots. These are roots, but they're not real. But I can put them together. I can write this as x minus 2i times x plus 2i. Okay, watch this now. X squared minus 2i x plus 2ix minus 2i whole thing squared. These cancel. This is x squared minus 2, that's a 4, I squared, x squared plus 4. That's what this is, right? Remember that irreducible quadratic? That's what this represents. So when I factor this big thing right here, this big thing really is something times something times something, and this was like the leftover piece, x squared plus 4. Well, I kind of got to work backwards now. Since I have this root, and I know that this is supposed to be a root of this, there should be a remainder that's 0. So I'm going to go at this a little bit backwards from the other problems. I know this, I know this. Oh, I know what I'll do. I'll just do this. X squared plus 4. I'll do long division, the dreaded long division. Now you will have a problem that uses synthetic division. We did so much of that in class. I think you know how to do that pretty easily. Okay, how do I do the dreaded long division? Well, what do I need to do to this to make it look like that? X. Okay, so x times that, x cubed. X times this, 4x. Subtract. Well, I know that's 0. I know that's 0. This is a minus 4x squared minus 16. What do I need to do to this to make it minus 4? Minus 4 times this gives me a minus 4x minus 4 times that. Minus 16. Oh, this worked out good. That minus a minus, 0, minus a minus. There's no remainder. That means this thing went into this perfectly even. What's the other root that I was searching for? And these other ones, I don't have any of these other ones because there is no remainder. So I kind of factored this a little bit backwards, right? So as reviewish, if you didn't know this, how would you have to attack this problem? Let's see, leading coefficient. I could have 3 real roots. How many positive roots could I have? Let's see, 1 sign change, 2 sign change, 3 sign change. I could have 3 or 2 positive roots. How many negative? You see